So this is to me one of the most revolutionary services that AWS has to offer, and I think it is currently underutilized. It's called AWS X-Ray. And the exam is really want you to know about X-Ray. I think this is why they ask the questions, because they want people to use it, and I honestly think people should use X-Ray. So when you do debugging in production, and I have debugged applications in production in the past, the good old way, what I call the good old way, is test locally, add log statements everywhere, and redeploy in production. And from the logs, try to figure out what is breaking, what is happening. It's pretty painful. It's not best practices. Obviously, there are better ways of doing things. I'm just oversimplifying things here. But you get the idea. Debugging in production is not fun. And then if you log stuff, if you have different applications, if you log from different applications to CloudWatch, then, they all have different formats, and it's really hard to centralize insights, and navigating CloudWatch logs is going to be hard, and analytics on top of it is going to be hard. So if you have a monolith, just one huge application doing everything, it's sort of easy to debug. But if you have distributed services, you're running 100 microservices in your AWS accounts, it becomes a nightmare. It's really, really hard to debug what's happening because they all talk to each other, right? So there's no common view of your entire architecture, your entire service map, etc. So here comes AWS X-Ray. So X-Ray is going to give you a visual analysis of your application. So this is what we're going to do in the hands-on. We'll see that basically as a client doing a request to our application, we will see how many of these requests fail or don't fail. And then from the application, we'll see what it does. So it will call other IPs, it will call SNS, it will call a DynamoDB table. And so as you can see, we'll be able to trace exactly visually what happens when we talk to our EC2 instance. And so, from this graph, if I ask you, where do you think that little orange or yellow error comes from? Well, is it coming from this? No. Is it coming from SNS? No, it is coming from my DynamoDB table. You can see it visually. And so that's the whole power of tracing. Obviously, you can do more, but you start getting the idea. In terms of X-Ray advantages, there's many. You can troubleshoot the performance of your application and identify bottlenecks. You can understand the dependencies in your microservice architecture because you can visually see what is happening and how all your microservices interact with one another. We can pinpoint then which service is giving us issues. We can understand how each request is behaving and then find errors and exceptions based on the request. We can answer questions such as, are we meeting time SLA in terms of latency or time to process a request? And we can understand which service really slows us down, throttles us. Finally, we can know which users are impacted by our errors if we wanted to. So X-Ray has a lot of compatibility. It's compatible with AWS Lambda, Beanstalk, ECS, ELBs, API Gateway, and EC2 instances or any application server, really, even something you have on premise. So they really made X-Ray try to be as wide as possible and as applicable as to any application they can. So X-Ray, how does it work? Well, it leverages something called tracing. And tracing is an end-to-end way to basically follow a request. So when I make a request to, for example, my application server, each component that will deal with a request, that could be my database, that could be my gateway, my load balancer, my application server, each component dealing with that request will add its own trace. And so the trace will be made of segments, and segments can be made of sub-segments, and the idea is that we can also add annotations to traces to provide extra information around what happened. So when all these things are together, you have the ability to trace every request or sample request. So you say, I only want to get a percentage of the total request, or maybe 5 requests per minute. In terms of security, there's IAM authorization, and you can use KMS for encryption at rest. So once you get all these traces, basically X-Ray provides its magic and provide this nice little graph that I showed you before. Now, how do you enable X-Ray? Well, you have 2 ways, and I think this is what the exam will ask you about. So you need to be very careful here. Your code can be Java, Python, Go, Node.js, and .NET, and it must import the AWS SDK. You need very little code modification, but you still need to do some code modification. And then the application SDK, the X-Ray SDK, will then capture the calls to the AWS services, the HTTP and HTTPS request, and the database calls for MySQL, Postgres, and DynamoDB. It can also capture queue calls, and so on. Now, the second thing we have to do once we've modified our code is to install the X-Ray daemon, or to enable the X-Ray AWS integration. So if we run on a machine on-premise server or EC2 instance, we need to install the daemon. And the daemon is basically a little program that works as a low-level UDP packet interceptors. It can be running on Linux, Windows, and Mac, and so you have to install it on your machine. If you use AWS Lambda or other services that already have integration with X-Ray, then they will run the daemon for you and you don't have to worry about it. Now, each application also must have the IAM rights to write data to X-Ray. So a very common question is, hey, my X-Ray application works on my computer when I test locally, but doesn't work on my EC2 machine. Why? Well, the answer is probably because on your machine, you're running the X-Ray daemon, but when you deploy to your EC2 instance, it's not running the X-Ray daemon, and therefore X-Ray doesn't see your calls. Now, to make it really crystal clear, here is an EC2 instance, and you need to have your application code on top of it. And so your code, again, needs to be modified to import the AWS X-Ray SDK, and then it will send its traces to the X-Ray daemon running the machine. So as you can see, you also need to run the X-Ray daemon, and that X-Ray daemon will send a batch every 1 second to AWS X-Ray. So X-Ray does some magic, and so to obtain this graph, how does it work? X-Ray will collect all the data from all the different services sending traces, and then the service map will be computed magically from all the segments and the traces. And so that's a really cool thing. X-Ray is graphical, so even non-technical people can help troubleshoot. Talking about troubleshooting, what if X-Ray is not working on EC2? As I said, you need to ensure that the IAM role has the proper permission, and you need to ensure that the EC2 instance is indeed running the X-Ray daemon. If you want to run it on Lambda, it's a little bit different. For it, you need to ensure that the Lambda has an IAM execution role with proper policy. And I know we haven't seen what Lambda is, but it's just a question you may get. So you need to make sure that Lambda has the proper IAM role that's expected. And then you need to ensure that the X-Ray code is imported, and also that the X-Ray integration is enabled on AWS Lambda. We'll see this on the hands-on anyway. So that's it for the overview of X-Ray. Little taster. In the next lecture, we're just going to run the sample apps on X-Ray to get a better feeling of how it works. So see you in the next lecture.